Hey everybody, let's continue with this problem now. It's pretty much the same problem. The only thing I've done is I've designated, as we saw in a previous video, the roller support has a force upward of 625 pounds, and the pin support over here at B has a force of 25 pounds upward. And so what we want to do now is find the bending moment and the shear force at arbitrary locations. And so J, K, N, and L are arbitrarily going to be some distance x from A, from the far left-hand side. Just trying to be consistent with the left-hand side being the origin, moving in the positive x direction. N comes after L. Of course, I don't use the letter M because we've got that with moment. And we're going to save that one for another video, actually, because things get really interesting in here. But we're going to have these various regions, right? So we're going to have a region, J is between A and B, K is anywhere between B and C, N is between C and D, that will come later again, and D to E is going to contain the value L, or the position L. Again, some arbitrary distance from the left. Okay, so let's take a look at the equations then for these three regions, and we'll get to that fourth region, N, in a little bit. So we've got a shear force down of V. Remember, down is always positive. That's, let me rephrase that. Down by convention is how we draw V. And if V is positive, then it's pointing down. And if it's upward and it's negative, I know that's backwards from what you're used to, but that's the convention that's used. All right, so if I look at the sum of the forces, I only need to worry about the y direction. I've got minus 200 pounds minus V, that's equal to 0. And so V is equal to minus 200 pounds. And then when I look at the sum of the moments, and again, I'll choose those moments about point A. That eliminates the 200 pounds from the moment equation. I'm going to get V, which is, I'm going to stick with the downward motion, or position rather. V is in the clockwise direction as it tries to rotate around point A. And so that's going to be minus V times X, right? This is some arbitrary distance X right there. And then plus M, and that's equal to 0. And so M is equal to Vx, V times X, which is negative 200 pounds times X. Okay, so the shear force is going to be a constant value, and the bending moment is going to be bigger, or more negative, really would be the better way of saying it, more counterclockwise, or clockwise, excuse me, more clockwise, as X increases. All right, so there's my sum of the forces. Sum of the forces in the Y for this region now, so we're between B and C, so we're at point K. All right, so I'm actually going to label this M sub J and V sub J because that's in that domain. All right, so the sum of the forces in the Y, I've got minus 200 pounds plus 25 pounds minus V, that's equal to 0. And so V is going to equal negative 175 pounds. And I'll go ahead and subscript that with a K. And then some of the moments, again, I'm going to go about the far left-hand side, point A. V is trying to rotate it clockwise, so that's negative. All right, so I'm going to have a negative Vx. The 25 doesn't do anything. The 200 rather doesn't do anything because that's at point A, right? So the moment arm is 0, or the lever arm. And then 25 pounds, that's going to be counterclockwise, so plus 25 pounds. And that's strictly at 3 feet, right? Point B is at 3 feet. Plus M, that's all equal to 0. So M is equal to Vx minus 75 foot-pounds, which is, V is negative 175, so negative 175 pounds times X minus 75 foot-pounds. And I'll go ahead and subscript that M with the letter K. That's supposed to be a K. All right, so we found those two regions. Again, a function of position, right? The moment is a function of position, but the shear force is constant in that region. Okay, we're going to skip the C to D region. We're going to move on to the L region. So L is going to be some position arbitrary there, and it's some distance X from point A. All right, so Sum of the forces in the X, or excuse me, in the Y, negative 200 pounds, plus 25 pounds, minus 150 pounds. That 150, you may recall from a previous video, I have 100 pounds per foot. The area of the triangle, 1/2 base times height. The base is 3 feet. The height is 100. So 3 times 100 is 300. 3 feet times 100 pounds per foot is 300 pounds. But it's 1/2 base times height. So it's going to be 300 divided by 2, so 150 pounds. And then recall the centroid of a triangle is 1/3 of the distance from the base. In this case, the base is the right-hand side. And so it's 3 feet, so 1/3 of 3 feet is 1 foot, so 1 foot from the base. The base is at 9 feet, so that's going to be at 8 feet, right? So that's why I've labeled that at 8 feet. All right, and then plus 625 pounds. And that's all equal to 0. Oh, wait, minus V. And that's equal to 0. And so V is equal to 625 plus 25 is 650, minus 150 is 500, minus 200, so that's 300 pounds. Okay, so the shear is 300 pounds, which is good because it's going to be done with that here. And then some of the moments again around A. So 200 doesn't do anything, 25 pounds. A, 25 is trying to rotate it counterclockwise. So 25 pounds times 3 feet. This is trying to rotate it counter or clockwise, so minus 150 pounds times 8 feet. Plus 625 pounds, because 625 is going to be in that direction, in the counterclockwise direction. 625 pounds times 9 feet, and then minus Vx plus M. And all that's equal to 0. And so M equals Vx, but V is 300 pounds. So let's go ahead and put that in. And I'm going to go ahead and subscript this with an M sub L. So that's going to be 300 pounds times X, okay? And then I've got to put all this other stuff. So here's 75, and 150 times 8 is 1,000. Right, did I do that right? 800 plus, no, it's 1,200. Okay, and then 625 times 9, that's going to be 625 times 10, which is 6250, minus 625. Don't have my calculator here, right? So 5, 2, and then 56. And that's positive. This is negative. 75, that's going to be 5,700, minus 1,200. So assuming I did everything correct, that's 4,500. So plus 4,500 foot-pounds. I don't care if you want to call it pound, feet, or foot-pounds. I probably should care, but I'm not going to do that right now. There's our value for the moment inside of that region where L is located. All right, stay tuned. Next video, we're going to tackle this section because it's pretty interesting. All right, see you in a minute.